welcome to my channel, Context MCU. From today, we will begin to learn the embedded software development on STM32. I hope you can become a embedded software specialist from zero through these tutorials. Today is the first episode, so we will start with the introductions to STM32. So what's STM32? STM32 is a family of 32-bit ARM Cortex-M series and microcontrollers. So it's widely used in embedded systems for IoT, robotics, automobile, and more. So why we learn the STM32? Because it's high performance, low power consumptions, and rich peripherals. Also, it's large community support and extensive documentations. Before learning the STM32, there is some things prerequisites, including the knowledge and the tools. First, the C programming language is essential for embedded development because in most cases, we develop the embedded software on STM32 by using the C languages. C++ is a good choice, but most of the developers only use the C programming languages. And the official SDK provides the C programming language, not the C++. So the C programming language is essential for the embedded development. The basic understanding of the electronics, like the general purpose I/O, resistors, capacitors, and etc. But it's optional. Familiarity with the microcontrollers, for example, Arduino, Raspberry Pi, it's helpful, but it's not mandatory because in this series of the tutorials, we will cover such topics in the incoming episodes. So it's optional, not mandatory. What's the tools to learn? Maybe we need to learn how to use the multimeters, oscilloscopes, and the breadboard. But like the above one, it's not mandatory, it's optional. It's better to have. We also need some required hardwares, including the development board and the debuggers. The essential components including STM32 development board, for example, STM32 Nucleo Discovery or Blue Pills. In this series of the tutorials, we are using the Nucleo H563ZI. You can see here is the board of the Nucleo H563ZI. So there's two Type-C connectors. You can connect to the board by a USB cable, and then you're able to debug and download the firmwares onto the board. The USB cable is essential for programming and power. Next one is jumper wires and the basic components like LEDs, resistors, and buttons. But also it's optional because we are using the Nucleo H563ZI. There is already built-in LED and the buttons inside the board. The button with the blue one, and another button is black. It's a reset button. Also, this LED is here. It's a little bit small, but we will light the LEDs in the future. Next one is optional but useful. ST-Link Grammar Debugger is not integrated into the board. By the way, if we use the nuclear board, there is a built-in ST-Link programmer and debugger. We just connect the USB cable into the USB Type-C connector. We are able to program and debug the firmware with the cable. So we don't need to buy another ST-Link programmer debugger device. The next one is sensors and actuators for advanced project. But for now, we only focus on the built-in sensors, so it's also optional. But if you have such sensors, it's better. So it's better to have. There is some software needed to be installed, including the IDEs and the drivers. The development tools include STM32 Max. Graphic user interface. You can configure the pin and any peripherals, and link them and configure them, and enter some number and enable, disable, all kinds of the configurations. Then you can click some button to generate the code automatically. Then you can use the code directly. So you don't need to write the code line by line. So it's very efficient. These include STM32 Cube IDE, Keil, or Platform I/O. In this series of tutorials, we use the Keil. I think most of the firmware and embedded software could be developed by the Keil IDE. Another one is serial terminal, PuTTY terms for debugging. Oh, by the way, Keil IDE is only available on Windows operating system. So the Linux, Macintosh OS cannot install the Keil IDE in this moment, maybe in the future. And the drivers. Install the ST-Link drivers for programming. By the way, drivers will be installed with IDE automatically, so you don't need to install the drivers separately. It will be installed together with IDE. Next one is USB to serial driver if you use UART communications. For learning paths, step by step, I recommend that start with basic. For example, learn GPIO programming. Simple project also called light the LED. The second way is explore peripherals. For the single chip microcontroller, the peripherals is very huge. So learn STM32 typically means learn the peripherals, including the timers, PWM, ADC, UART, I2C, SPI, all kinds of the peripherals. Advanced topics just like the real-time operating system, FreeRTOS for multitasking technology, and the low power mode, DMA, and interrupts. You are able to build the project, create a new real-world applications, just like the weather station, robot, IoT device, any kind of the interesting project. Hands-on practice is essential, crucial, and important to a developer. So you can begin with simple projects just like blink an ID, read and button input, and control a RGB LED and from very simple project. Then progress to intermediate project. Sensors, for example, temperature, thermometers, communicate with the PC via UART. Also, you can communicate with another board, another chip via UART. Advanced project include the build a motor control system. So after you learn the timers, PWM, you can start building a motor control systems. An IoT device with Wi-Fi, Bluetooth, and so forth. We also need to avoid some pitfalls, just like skipping fundamentals. Don't rush into advanced topics without understanding basic. Simple and gradually increase complexities is the good practice. Ignoring documentations. Documentations is very important for us. Maybe if you read the reference manual of the STM32, it's huge. Maybe it's more than 1,300 pages for the reference manual. So please don't expect to read the entire reference manual. But it's a manual. You can refer to the manual frequently. If you want to start a timer, set up a timer, you can then go to the paragraph of the reference manual to the timer, and then read the sections of the timer carefully. So don't ignore documentations. All kinds of skills or knowledge documented in the reference manual and other manuals. In other words, giving up too soon. Learning the embedded software development is boring. The learn curve is very steep, very long. So don't give up too soon. Embedded development can be challenging but rewarding. Okay, everybody, it's pretty much for today. If you have any questions, please leave your message in the comments area. See you soon. Bye bye.